Welcome to Yaka Digital Network videos. In physics, movement is classified by its path. When a matatu travels in a straight line down the Kampala and Tebe Expressway, it is performing linear motion. When a Uganda Cranes footballer kicks a ball at an angle, the ball follows a parabolic curve, which is nonlinear motion. To measure these paths, we distinguish between two concepts. Distance is the total length of the path the object covers. Displacement, however, is a vector. It is the shortest distance between the start and finish points, measured in a specific direction. This distinction affects how we measure speed and velocity. While speed is distance divided by time, velocity is the rate of change of displacement. Because it is based on displacement, velocity must always include a direction. For objects moving in a straight line with a steady change in speed, we use these four equations of uniformly accelerated motion. Here, U represents initial velocity, V is final velocity, A is acceleration, T is time, and S is the total displacement. For example, if a matatu starts from rest and reaches a velocity of 20 meters per second in 5 seconds, we can find its acceleration using the first equation. By substituting our values into V equals U plus AT, we find the acceleration is 4 meters per second squared. These four equations allow us to calculate displacement or velocity for any object with constant acceleration. Let's apply this to a specific problem. If you drop a stone from the top of Worker's house in Kampala, how far will it fall in 3 seconds? To solve this, we must identify the variables hidden within the description. The word dropped tells us the stone was released from a stationary position. This means the initial velocity, U, is 0 meters per second. Since the stone is falling, it is accelerating downward due to gravity. This gives us a constant acceleration A of 9.8 meters per second squared. With U, A, and T identified, we need to find displacement, S. We choose the equation that links these four specific variables. Identifying specific terminology like dropped is as important as the calculation itself, as it provides the initial velocity required to solve the equation. Now pause the video. Substitute these values into the formula to find the displacement, then press play to check your work. When we substitute 0 for U, the first part of the equation becomes 0 times 3. This effectively cancels out, simplifying our calculation. We are left with half of 9.8 multiplied by 3 squared. This results in 4.9 times 9, giving us a total displacement of 44.1 meters. Systematically listing your known and unknown variables at the start removes the complexity from word problems and makes the solution clear. To interpret motion visually, we use graphs. Let's map a YY coach's bus journey on a velocity time graph, starting as it leaves the park. As the bus accelerates, its velocity increases at a steady rate, represented by a straight diagonal line sloping upward. Once the bus reaches cruising speed, the velocity remains constant. With no change in velocity, acceleration is 0, resulting in a flat horizontal line. When the bus brakes to a stop, the velocity decreases to 0, shown as a downward diagonal line. On a velocity time graph, the slope of the line equals the acceleration of the object. This summary brings the equations and graphing rules together for easy reference. You can watch more videos for all classes here and get all content at www.yaka.cc.